Welcome back to the tutorial of image sensing and acquisition. Now, what exactly image sensing and acquisition is? Image acquisition is the first step in any image processing system. The general aim of image acquisition is to transform an optical image, which is nothing but your real world data, into an array of numerical data which could be later manipulated on a computer. If I talk about any digital image processing, it is basically the modifications of different kinds of images on a computer. Now, these are the basic elements of an image processing system: image acquisition, image storage, image processing, display, transmission. Now, this exactly is image acquisition. We have also seen about image acquisition in our very first tutorial. We'll revise the concept again. This is the scene element. As light falls on the scene element, which is also our object, it is projected on the imaging system. From the imaging system on the image plane, the image is projected. This is your actual image of the object, and further, this image is projected on some other screen, which is nothing but your digitized image. This is the final digital image of my system. So this is how an image acquisition works. Now, talking about quantum detector. Quantum detection is the most important mechanism of image sensing and acquisition. Of the several modes of operation of quantum detectors, the most important ones are two. We are going to learn about photoconductive and photovoltaic. So this is how a photoconductive looks like. Now, talking about photoconductive, the resistance of photoconductive materials drop in the presence of light due to the generation of free charge carriers. An external bias is applied across the material to measure this charge which is formed, and this principle of photoconductivity is used in Vidicon imaging tubes for image acquisition. So this was about photoconductive. Now, talking about photovoltaic. Photovoltaic basically consists of semiconductor junctions. They are solid state arrays composed of discrete silicon imaging elements known as photosites. As you can see, we have here two types of arrays: line arrays and area arrays. In line arrays, they basically consist of one-dimensional array of photosites. And talking about area arrays, area array or matrix array consists of two-dimensional array of photosites. The next element that we have is image storage. Now, if I talk about image storage, here all the video signals are essentially in analog form. That is, electrical signals convey the luminance and color with continuously variable voltage. So basically here, the cameras are interfaced to a computer where the processing algorithms are written, and this is done by a frame grabber card. So here, friends, we have a very much simplified diagram of a frame grabber card. So these are the different elements that are in the frame grabber card. Frame grabber card has a block of memory which is separate from the computer's own memory, which is large enough to hold any kind of an image. This is known as frame buffer memory, which is different from the memory as that of the computer. The image data here usually is in the form of bytes. 1 byte is equal to 8 bits, and this is where you can see the data is being transferred. Further, what happens is, this data is written into the frame grabber memory under the computer control. As you can see, this is the computer bus and this is the controller. So this data under their control is written usually by DMA transfers. The contents of the memory are continuously read out at a video rate of 30 frames per second, passed through the D/A converter and displayed on the memory. So this is the entire flow. The data passing through the analog or digital is further passed to frame buffer memory, which is the own memory of the frame grabber card, which is different from the computer bus controller. And under their control, the data is further transferred by DMA transfers, and this data through D or A converter is further displayed on the monitor. So this is the entire flow of the image storage. Now talking about image processing. Systems ranging from microcomputers to general purpose large computers are used in image processing. So basically here the frame grabber cards play the important role of merging the image processing hardware with the host computer. It is characterized by specific solutions, and the image processing software that is used here is MATLAB. The next element that we have is display. The display device produces and shows the visual form of numerical values which are stored in the computers as an image array. As we had seen earlier that we store the data in the form of an image array, that particular array is displayed by using these devices. So principal display devices that we all are familiar with are printers, TV monitors and CRTs. And any erasable raster graphics display can be used as a display unit with an image processing system. Now this is transmission. In transmission, we have tried to demonstrate the entire process in the form of a flowchart. So basically what happens is, the image sequence from the camera. As you can see here, this is a scene, the reflected light and then the camera. So basically here, the image sequence from the camera is coded into as concise a representation as possible for transmission over the channel. So basically what happens is, the image sequence from the camera is coded. After encoding it here, it is passed through the transmission channel, and further after reaching the destination, it is at the destination side decoded, and this data is further displayed on the display device, and this is how the human eye is able to perceive and see the image. So that's all about transmission. Thank you.